Okay. Trying to see. Okay, yeah. Okay, so Dr. Awule has actually taken you through so much, and I thought that I mean, I actually believe, though I've not discussed with you, that this is the way we should go as we are teaching. Can you hear me clearly?
Yes.
Hello? Yeah, as we are teaching the basic of Python, so that people can start using this data analysis, or as a data scientist can start working. We also start doing the interesting stuff. Now, knowing pandas, if you know pandas, then you can work well with pandas. You can manipulate your data very well, because in any analysis in real life, the most important thing, I mean, 80% of your time will be spent in data wrangling. And once you can handle that, which you will do with pandas anyway, then even modeling will become easy, because with modeling, you are just running algorithm and tuning algorithm. So I will just, the same thing Dr. Awule demonstrated to you. I'm trying to look for a clean, can you see my screen? Hello?
Yes, yes, we can see
Hello?
it. We can see your
Yes,
screen.
yeah, okay. So I just, let me just use one of these small data set I have with me to demonstrate some of these things. Yeah, of course, he has also told you about how to import pandas, and we try to assign PD. We call it convention over configuration. It's easier to be typing PD all the time instead of typing pandas anytime you want to invoke any pandas function. You better to type PD, is shorter. Also, along with pandas, another important library that you need as a data scientist, though as you are importing pandas, it's important, but it's also good to, as a matter of practice, to always import NumPy, numerical Python. That is what it means. Because for any number manipulation that you want to do in data science, you will actually need NumPy. It's a very complex and a very robust library. So, like you said, you import. The other thing is that try also to separate your codes into cells as much as possible. Then comment. Like if you can see my screen, actually I was toying with different topics here. What question do I answer in this particular data? This work is like over 3 years old. So now, please ignore all these other libraries for now. We have not reached this stage. So import, and just like you have said. Now, you are working in the Google Colab environment. This is on my own, Jupyter notebook at home. Like I said, Colab is good because you can lie down in your bed and just run. And some algorithms, you have to run them. They take time when you are tuning them. So just like he has explained, sorry, I'm going through this again because it is very important to know the nuances again, over and over again. So the first things you usually want to do is you want to have your data, and he has explained to you the read CSV. Now, if you look at it, this is slightly different from what he did. You see, I'm importing this data and I'm specifying the full path on Windows, because this file, this IPYMB file, this is Jupyter notebook file, is not in the same directory with the data. So I'm specifying the path, the full path. Well, if you notice, there is an R in front here. What this R means is that it's like an escape function, because I'm using Windows addressing system. And so that Python will know that, okay, please read this thing as an expression to import. If I remove this R and I try to run this code, I'm going to get an error. See, because Python will not understand this backward slash. So that is another way of doing this. Way of doing this to put this R. And when you do this, you'll be able to import. Another way of doing this is to change all this one to forward slash. But that can be laborious depending on everything down the line, or to forward slash. Okay, you are following me? Okay, so this accomplishes the same thing. Then you will not need this R. And when you do this, you can import. Now, When you import your data sets, you want to do some sanity check. So let's do some. And those are the things that Dr. Ameye was trying to explain to you. We want to even see this data. What is it about? So the first thing, like he did, was what I have named this data set voice data. I could name it anything, but this happens to be the naming I used for this data set. Okay. So, okay. Okay, yeah, info. So when you run this gives you info. And there are lots you can see from this data set already by running the info. You can see said 120 entry, 0 to 119. And it tells you the number of non-null. Because let's say we have, for this age, let's say we have 110 non-null. That means we are almost sure that, okay, there are like 10 missing values already. So that gives you an overview. This is a small data set, so the loading is a bit faster. And you can see all the columns and their names and the types that they have. Age, sex, all those. Now, whether the subject is a test or whether they are controlled. So everything is there. Now, and the lesion, if there's any lesion in the, this is a clinical data. So any lesion in the larynx. Now, the next command that's also important is to know the shape of the data. So you can also remember, we are still referring to this voice data. That's the name of our data. You can say voice data. It's because it's not all in all cases that so this is a property, so you don't need to put bracket at the end. It's not a command. Then this will give you, this will give you the shape of data, which is telling you that there are 120 rows and 16 columns in this data set. So that's the way of knowing the number of rows and columns. It could run into millions. Maybe I will have time to show you examples later on. Now, all this is a way of doing some sanity check and trying to understand your data. Another test that you need to do, like Dr. Ameye showed, was to describe. And what describe does when you run that command plainly is that it takes the numerical values in your data set and tries to give you their summaries. People call it 5-point summary. The mean, it gives you the mode, it gives you the mean marks, and the first quartile, second quartile, and the third quartile, and all those details as you see now. So if you say voice data dot describe, remember, it's a command. So it takes only the numerical data. If you look here at this now, you'll see that it didn't show lesion, because lesion is really not the numerical data in this data set, and has given you all the summary. But this view can be at times difficult to understand or to appreciate. So if you want it to look more elegant, you can just do .t, which T means to transpose. And when you run the same command again, you have this, which appears more elegant and easy to follow. So now, we have dropped lesion. We are not seeing any information about lesion because it's a categorical, it's an object data type. So what if you want to see the summary? And you can have data set that will have many categorical data like that, and you want to see their summary. I will show you one now, another one. But for this one now, so this is what you run. You can say voice data. I prefer to run this dot describe. Then you go into bracket and say include. And say this object. That means include the object data type. Then, like I said, I like to transpose all the time, .t. So when you run, so it will give us the summary of this. The lesion 120 count, so we don't have any missing value. There are 2 unique values. Actually, in this particular work, we say that it is normal or abnormal. Then the top frequency is no, and the frequency of that top frequency is 99. That means 99 of the of lesion actually is registered as no. So that is it. So this is part of what we call your exploratory data analysis. I'm going to switch to another data set. Let me see if I can find another data set that's okay, that's actually explain this better. Okay, good. So this is another data set. Okay. The same mechanism we import. Okay. And if you see, I try to put checkpoint markup so that I will know where I am. Now, in this case, look at it. The file, low modeling, is actually residing in the same folder with the IPIMB file. So I didn't have to put any long addressing scheme. So I just import the loan data and try to read the comment I wrote here. I said, let us have a copy of our pristine unaltered data to avoid destructive analysis of data, because what we are trying to do, advantage of analytics like R and Python is that you can analyze your data without having to destroy the original data set. So I'm actually now making a copy of that. So is that copy I'm going to do all my analysis on. So, and this is an industry code. So you can see I've made a copy. So now the same command, I ran the same command. Now we have 5,000 entry, and you can see the different data types. Now, the same command I ran earlier about the shape, this time around, I'm reading out the values of the shape. The first item in the shape, Python location scheme is based on, it starts with 0. So from 0, 1, 2, 3, 4, 5. So, and so on and so forth. So the first item is shape. The shape is the row. And the second item is the column. So I wanted it to come out as a sentence. So that's why I said print the data set as data.shape, address 0, and rows, and data address 1 column. And when you run, so now, Dr. Awune already showed you the add function. There's also another function called tail. Add without any parameter will show you the first 5 rows. Tail without any parameter will show you the last 5 rows. But if you say add into bracket 10, add into bracket 10, then you have the first 10 rows. If you say tail into bracket 10, then you have the last 10 rows. But I like to use sample, because sample selects the number of rows to specify at random. And why I like samples at times is that each time you run it, number one, you get different results. Number two, you may be able to highball some abnormal entries, anomalies in data set when you run your sample. So let's run this sample. So instead of dataset.add, we are running dataset.sample. So, and this is it. So I'm sampling it. I just randomly sampling 10 rows. Yeah, and you can see this part that is bolded. This is the index of data. You can see they are not sequential. So if I run it again, you can see the first one there now is this index is 2732. If I run it again, let's run it again. So now it's 1546. So it selects as random, so I can eyeball the data and see, okay, are there any anomalies in this data? Are there things that I want to, that look strange? So that's that. Now, okay, so this is just coming early, because this data set has a data, and it has an information that is useless to our analysis. So you want to remove that column, just like you are doing analysis in your on maybe you collected data and you numbered, given your respondents serial number. That serial number has no bearing on analysis. So that is the reason for this next command. And the idea is that I want to drop it. Now, this is the command, data.drop, the name of the ID, of the column, which is ID. Then axis. Axis in Python means this is 0 axis. If you say drop, you are dropping row without axis, that's 0. Axis is equal to 0. If you say axis is equal to 1, that is column. Just take it like that. I will explain in detail later on about this axis. So I'm dropping this data set, this ID, and I'm assigning axis. I'm dropping along this axis. This is axis 1. This is axis 0 is, let me annotate. This is axis 0 along the row, axis 0. Axis 0, can you see my marking? Sorry, my mouse is capricious. Now, this is axis 1. Sorry, axis 0, axis 1 along the column down. So I'm dropping ID. Sorry, I'm dropping ID. I'm dropping this ID along axis 1. And when after that, I now run the describe again, just like I ran before. And you can see, how do I remove all this? Okay, annotation. Okay. Okay, remove. Okay. Okay. Yeah. So you can see the same code we ran earlier, the same describe. Minimum, maximum, standard deviation, first quartile, second quartile, third quartile, then maximum. Like, and Dr. Awule said, this actually allows you to spot on abnormality. And if you can see in this data set, you can see minimum is -3. Are you following me? Are you following? Hello? Hello?
Yes,
We are with you.
sir.
We are
Yes,
with you.
sir. We are with
Yeah,
you.
yeah, you can see -3. Can somebody have negative experience? Even if it's possible, at least you may need to call your client back and say, well, in your data you gave me, I saw that there's in the experience feed, I saw some people with negative value. Did you deliberately record that, or that's just a mistake? Maybe somebody was meant to enter 3, was feeling and sleeping like I was today, and entered -3. So those are the. So let me look at the charts. Is anything I have to answer? No. Okay. 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 So at times you want to. Okay, this is just handling negative value. I don't want to go into that now because I will just make it a bit complicated for you. Okay, so let me go back to my other data set to show you some other things you need to do on data. Okay, where's my PLMB? So okay, good. Sorry. Okay, so I think this one. I'm not sure I did a lot of exploratory here. Okay, so this is another data set. Let's just, I'm trying to take data sets, so without taking you through what you don't need so much. I mean, okay, so the same command, info, just sanity, I call it sanity check. So then this is just a command I just wanted to see, so don't bother yourself about this for now. Okay, so now describe again. See, the same thing, the same methodologies, DFtrain dot describe. Don't forget this because this is a function. Then time dot T to transpose because this gives you, or in my own opinion, better view. So when you run this, so you see the data, and then the same command I explained to you earlier. Describe, now this time include objects. If you say include all, it's going to show the summary of everything, both numerical and object, but I like to separate them, include objects, and you can see. So this is about a restaurant. This is the data of a restaurant. So of different restaurants in the city, and you're trying to model their income. So you can see the object data types you have is the cuisine, the city, the restaurant location, opening day. Now, at times when you run your data, you see some abnormality. Opening day of a restaurant should be a date, which is what we will still address later on in the data set. I address that in that data set. Then endorsed by restaurant type. They are coded as a number, but really they are categorical. Then the restaurant team. So the top restaurant team is Arabian team, and this occurs 1,373. Now, Dr. Awule already started you on what we call Pythonic slicing. It's a big topic on its own, and you really need to understand how we do Pythonic slicing, how you select rows and columns. But let me use this small data set to explain to you. Now, like I've said,
Dr. Ameye, before you go on,
okay, yeah,
there are some questions in the chat box which I would like to attend to.
Okay.
Somebody is asking that is there a template for coding which is inbuilt in the app?
Well, not really, but like I gave you an advice. If you followed my first lecture, you see, all your work will be the same, or let me say essentially the same. I already said there's 80% data wrangling. And with that data wrangling is that you are manipulating your data to make it suitable for your analysis. Handling missing variable, checking the value, finding them. Then after that, you do what we call exploratory data analysis. After that, then you do whatever other analysis that you are under exploratory. That's where you do univariate, then multivariate. Then after that, then if you are into modeling, then you start your modeling depending on the algorithm you want to use. Now, there's really no template, but believe you, let me explain to you that you have to do a lot of reuse. So I already have it in my mind when I want to do any analysis on any data to follow that pattern. And you have to copy code at times between works. You see, I cannot remember some of these functions offhand all the time. You know, if I have a good function I used to plot a beautiful graph before, I can just bring it again to another work and just modify it and use it. So there's really no template. Yeah. So somebody says, so here are object is string variables. Yes, object are the string variables here. Yes. In pandas, objects will be the string variables will be objects. I think there's any other question there? Okay. I think those are the questions.
Yes. We just have about 5 minutes or thereabout to go. So if you can just try.
Okay. So Pythonic slicing is what Dr. Awole was trying to explain to you. So you want to select. So let me just say voice data. I'm not going to assign them to another data set. I will just use this to show you. Now we have two methods. You use the number, ilog. It's the only function I know in Python that you don't use parentheses. I mean, you use a square bracket. And ilog, sorry. Now, this is ilog. That means integer location. Now, you have two locations in a data frame, the rows and the column. So you see, I put a comma in between, ilog, just to let you understand. Maybe that is a template. Now, if I want to select first 5 rows, that will be ilog. You know, Python starts from 0. You understand? The indexing starts from 0. Then you use colon. Now, when you are using ilog, Pythonic slicing, the last element in your what you call it in the number you specify is not selected. So that means I'm selecting 0, 1, 2, 3, 4. Are you following me? So ilog, I'm selecting row 0. So the first thing is row. I'm selecting row 0 to row 4. Remember that 5 is not included. Row 0 to row 4. Then I want to select, maybe, I think in this set I have how many columns? I have 16 columns. Okay, cool. I want to select column 8, column 8 to column 10. So column 8 will be, the index of column 8 will be what? 7. Because addressing starts from 0. And I want it to get to 10. Sorry, to 10. So that will be 7, 8. That 7 is 8, 9, and 10. So I'm going to put 10. It's not going to select that 10. Sorry, this should be 10. It's going to be 7, 8, 9, which is column 8, 9, 10. And when you run this data, you can see, so it's selecting 1, 2, 3, 4, 5. And you're only selecting, this is the column 8, column 9, column 10. Let's say I want to increase this to 10, or I want to select 10. So this will now be row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is still 10 rows, but 3 columns. That's column index 0, index 8, and index 9. 10 is not included. So, or let's even modify it now. Let's even say we are selecting up to 12. So sorry, 12. So which will be column index 7, which is your 8th column, index 7, index 8, index 9, index 10, index 11. So let's see. So you see, This is in the 7, 8, 9, 10, 11. So this is one aspect of Pythonic slicing. Very powerful function, and you're going to use it a lot when you are modeling and you are doing okay. Can you see my screen? Someone said, who can see what you share here? Okay, it's okay, sorry. It's my own system that's small. So another way is you want to select the last row alone. And the reason why you select the last row alone is because maybe perhaps you want to remove that row, or you want to, maybe the last row is the dependent variable and you want to select it to another variable for model. So the same method, Pythonic slicing, if you don't specify anything before this comma, Python assumes that you want all your rows. Now, if you now say -1, I think this is all your rows and the last. Let's check. Maybe I'm right, maybe I'm wrong. Okay, sorry. What did I do wrong? Okay. Okay, so I have to specify the starting. So I think it's 0. Okay, 0 excluding the last. That is what I was supposed to do. 0, that is starting from the first column, but excluding the last column. Let's see if I'll get it right. What have I done wrong? Okay. Okay. Yeah. Okay. Okay. So now I didn't put the colon here. So I'm saying, Python, I'm not giving you any specification about the number of rows. Just take all the rows and select all the column except the last column, -1. And if you look at this data here, the last column was, I think when we ran the sample before, okay, do I still have my code for sample? Okay, okay, well, the last column is lesion. Okay, so let's look here whether we still have lesion here. You can even see saying 15 column, but let's see. And which is abnormal larynx, which is in this case actually the dependent variable that we are trying to predict. So at times we want to separate it into another data set. So that is why you can do things like, if I say -2, that means the last 2 columns will not be selected. So just the same way, that's another aspect of Pythonic slicing. So it's 14 columns and so on and so forth. So depending on what you are trying to do. Please, any questions so far on this? Yeah. So Dr. Ole also explained in some situation we want to use the column addressing to select the columns that you really need, and that is when you do voice_data, okay, into, and you specify. So double, and you specify the names of the columns that you want in a list like this. Like